Omega Key project. All right. So last year you heard a summary of all the different key projects. Today we will focus on the latest installment. The Omega Key projects started with the key project where the 10 led by Ethan Bachelay. And the idea was initially to extend the hunting grounds, if you like, for follow-up observations. And after that, a project, and including especially targets alerted by Gaia, ZTF, and others, the latest approach now shifts more towards events that are not as highly covered by survey teams at the very highest cadence. So we're looking at more hidden populations and longer events, which Gaia, by definition, provides. And two of the main objectives are measuring or contributing to the measurement of masses of isolated stellar remnants, whatever kind, characterize more planetary dwarf and stellar binaries, and use the existing, upgrade the existing infrastructure so it can be used and is ready for the Rubin alert stream. And hopefully we will see the first light and the first alerts later this year, and also expand on the EON network and use spectroscopy follow-up to further characterize our events. And this is a true team endeavor, and I'd like to only show you the names. They're even more involved in the whole key project, but I'd like to also give huge thanks to all the core team members looking after daily operations here in the room, namely Etienne, Katarzyna, and of course Rachel, SPI, who put this project so well together. We would like to now give you an overview where our new targets are, and I take the liberty of making a little bit of an advertisement. This is not the usual view you would see of targets, and you see here in the central Bulge region in blue, and this is arbitrarily colored, of course, the stars that we, or microlensing targets that we clearly won't observe, and in red in this planetarium show you will find the targets from our catalog that we have ingested in the database and in our observing program. And the little bit of an advertisement or advertising that I'd like to make is like to highlight the Gaia Sky code, which is a visualization planetarium VR software package that you can use to, in a 3D fly-through way, visualize your code. And this is part of our impact group, and this is something I'd like to just show to you. In a bit more sovereign way, now let us go back to the technical view. This is how the current database of Omega 2 looks like, of ingested targets. In red, we have outside high-cadence zone of survey teams located targets that will benefit particularly from extra observations. And we see also here more ingested targets. The most of them you will find they are so nicely distributed all over the sky. It can't be from Earth, and you're right with that because the targets are of course Gaia science alerts, and as you've heard in the talk by Markus, Gaia has reached the end of observations, and the mission will of course continue till the 2030s when the last DR5 data release is provided. And so the Gaia science alerts have provided these alerts and need of course some further vetting because the initial classification by the beautiful job that the team was doing in Cambridge and it also of course needs some further steps. So the hunting ground also applies something, and I think back that Matthias on a slide had a very similar one, but related to transits. Here I'd like to illustrate once more what the future will have has for us. We're having the regular microlensing targets reported with the different methods, measurements, or not measurements, and the other planet detection techniques. If I now ingest all the potential Gaia science alerts, this is how they would look like. And we can, of course, see that also in the sense of what Eamon, for instance, said, going and thinking about the break equation, that it will be very important to cover most of this parameter space and to actually boost this metric. So, and for that, of course, it will be ideally suited to include more Rubin, also Rubin events, which of course will not be will not look like that, but rather here the sector of the disk fields that Rachel have introduced, this boost, the cadence optimization committee recommendation, which will contribute here much more to a better and to a high number of microlensing events. So what the lesson learned is from the Gaia science alerts, microlensing is doable with Gaia, will certainly work for Rubin without any doubt, which some of our colleagues still seem to question sometimes. And it's important, of course, to say that the sampling interval of Gaia is much lower, modulo some cadence, especially intensified regions on the sky, where the scanning log contributes to higher event rates. So the idea is, of course, with that change, we will see more distant sources, also closer lenses, longer events. So these things from galactic structure, but also from observational selection criteria will give us new opportunities. So it is based, the system is based most on the observing systems of the target and observation managers. That is, the team is based, that provides the toolkit for that is based at LCO. And the key project here has already even two separate target and observation managers in place. One is dedicated really to the project and the test beds, and will also be the blueprint for what will be implemented, hopefully, as part of our in-kind contribution to Rubin. And the idea is, of course, you ingest events, you maintain a database, you keep track of changes and perhaps data reduction upgrades, and with a selection of analysis interfaces, you will then trigger observations. The black hole term, which is the system developed in Warsaw by Brzezinski's team, and that was just introduced also by Markus. I will not go into detail, but this can be a similar, can have a different priority, a different objective, and connect to many more different types of telescopes. So the very friendly ecosystem and coexistence of TOMS enables a very flexible approach for very different collaboration styles and use cases. So this is how such an event page on ModCloud will look like, and all kinds of data will be ingested. On the left side, you see event parameters, and as long as telescopes provide real-time feedback, we can visualize, see spectroscopy, photometry, manage data, see what's the latest edition of Etienne's Palima is giving us as far as this event is concerned. I have not shown this event completely randomly. We will come back to that in a moment. But there's one major upgrade, that's for the automatic operation. We're using two priorities now. And two priorities, the different algorithms will and can prioritize the event categories. One, which is the more stellar events, planet-like events that we've observed in the past, and it's the stellar random events that are the long TE events and candidates for those which are now also in the system. Thanks very much to Katarzyna's expertise and looking after that. This is now there. We'll also see, in addition to PSPL modeling, binary models, which is also in her in the work and part of her update. So we are seeing an improved handling of an ever-increasing number of new targets. Also, the number of objects increases in the database, and so we can see test the effects that we will see with other systems like Rubin. And this is now improved for this very project. So other upgrades are, of course, the observing strategy needs to be reflected, the priority mode for anomalies, so that if they are usually with 1 hour or manually to 15 minutes, cadence can be set. We observe events, usually stellar events, every 2 hours at peak, so within 0.2 Einstein time of peak, or every day, every 3 days. Otherwise, stellar remnants every 2 days. And in addition to these 3 strategies, also with a slightly lower cadence, we secure not only SDSS I prime, but also SDSS G prime data. at a lower cadence, the brightest events will also benefit and get fluid spectroscopy. So measuring the lens companion mass, for that we benefit from spectroscopy of source and lens. We'd like to collect as many observables as possible, and again has Polina's work shown very nicely how many observables can be accumulated to get all our classes here from the free-floating, non-so-bound targets to the darkest of all objects. And the events of interest that we've seen, I will only highlight two because they are both work in progress, and we want to leave it to the first authors. I've put this little warning here. We have 10,000 images so far in total, a couple of Gaia events, 6 from OGL, and from the OGL we will survey, and we will show 2 events that are of interest. One is OGL 2023, 1060, led by Paolo Wota, which is a binary event, which is the first one actually as soon as the system was online that we've picked up, with a mass ratio which is more on the order of 10 to the -2, so it is not necessarily a planet, but it's a good example how immediate the response was. The second one, Katarzyna had last night, and she's also the lead of this. More of this, more data is expected from various sources, but also we are not at baseline. Here you're seeing an increase, and this very short perturbation gives you an idea that this is probably a low map, or this is most likely a planet. You see here data from small aperture telescopes a little bit outside of the view. You see that this is a longer event, and actually this is an ideal event for omega-2 because it was prioritized because of both criteria. Planet probability, anomaly, and Einstein time beyond a certain limit. And based on that, it was then observed. And as I said, these are all orders of magnitude estimates. They're not the real last best fit parameters. So it's mass ratio probably 10 to the -4 milli-arc-second Einstein radius. So nothing. So this would not give you a clue what that is. And the spectroscopy gives us, it helps us a bit, perhaps Saturn, perhaps Jupiter mass range. But the host would be, of course, lovely. It is rather if it would be dark. But this is to be finalized. Mass and lens distance, thanks to PyLimas, can be estimated and motivate further follow-up to be between 0.4 and 0.6 solar masses and at 0.3 to 4 kiloparsec. But there is some blend. And thanks to Etienne's German IDT spectral imaging project with the Zorro instrument, and this can be only attributed to the inner 0.1 arcsec, and so to the to the lens, which would be unfortunate for really dark objects. So let's see what that means when the data is complete. I'd like to summarize this. So we are now focusing and paying more attention to the half of the survey events outside of the highest cadence zone, where we see properties, source properties, extinction, and event parameters differ a bit. So certain extinction maps cannot be used readily, and some of the old analyses have to be repeated, which needs some extra time. And the follow-up observation will continue to characterize long and short microlensing events. And exploring long duration microlensing events with planets or other companions, this would be basically the match and the next step. As referred, we see so many dark and stellar remnant targets, so orbiting targets, orbiting planets all around those are obviously here the next step. So, and this would be the end of my nominal program, but I have a further announcement to make because we would like to propose to host the microlensing meeting next year in Heidelberg. We don't want to step on anyone's foot. So if there's any other person who really feels strongly about it, just let us know. Heidelberg is Germany's oldest university and a very international town. We have a real astronomy hub with 7 astronomy-related institutes. We are based at the university. That means, as opposed to some other institutes, we're downtown in the most touristy region of the city. We, due to the teaching term, would suggest mid-February and February to host it. and would be delighted to talk about it most likely for 5 days. And at the end of the conference, I'm very happy to hear your feedback. Thank you so much.
You know, there's an IU working definition of an exoplanet. It sets the mass ratio limit at slightly above 4 times 10 minus 2.
Yes.
Between planets and non-planetary matter. That's supposed to be in addition to the upper limit of material.
Yes, this goes, I think, back to one of the first planets, where it's in 0.003, the microlensing expired as IU has taken it over.
Yeah, no, I was the one that came up with 0.03.
Okay, thank you.
0.04.
Okay.